Hello. Today we're going to be covering arithmetic and geometric sequences, which are very simple. And let's start with arithmetic. First, let me give you a sequence. A sequence is basically a set of numbers. It could be finite, it could be infinite. And let's say we have 3, 5, 7, 9, 11. If we subtract, starting from the right side, moving to the left, 5 from 3, we get what? 5 minus 3, which is simply what? 2. 7 minus 5, 2. 9 minus 7, which is simply 2. And this is 2 as well. You can tell there's a common difference, right? Now, this is not related to polynomials. This is a different chapter. Now we're dealing with sequences, not polynomials. And from the first difference, you should find a common difference. And if you get a common difference, then that means you're basically dealing with an arithmetic sequence. Now, let's say we have 2, 4, 6, and I ask you what's the next term, you would simply tell me what? 8, correct? We're adding 2. We're simply adding 2 after every single term. Now, you heard the word term, right? But what does that mean? Well, this is really important with sequences. The first term, in this case, is 3, right? It could be called A1, or it could be called A0, depending on the question. Now, if it's called A1, the second term would be called what? A2. But if it's called A0, then the second term would be called A1. So let's say you start with A1, then it would be A1, A2, A3, A4, and A5. Let's say you start with A0, it would simply be A0, A1, A2, and so on and so on. Now, let's have a look at these two examples. Is each sequence arithmetic? If so, find the common difference. They're asking us to determine whether each sequence is arithmetic or not. Looking at the first one, 2 minus 1 is simply 1, 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. Does this look arithmetic to you? Well, not really, so A is not arithmetic. What about the second one? 1 minus negative 3, which simply equals to 4, right? And you have 5 minus 1, which is 4, 9 minus 5, oopsie daisy, okay, 4. 13 minus 9, which is also 4. And this is definitely arithmetic. We have a common difference. You can try these two, 1 and 2, and try and determine whether both, one of them, or neither are arithmetic. Now, this is the general formula. AN equals to A1 plus N minus D. What does this exactly mean, right? Like, why do we have a formula right now? Well, let's say we have 3, 5, 7, 9, and okay, I do have a calculator next to me. And I tell you, you know what? Can you please give me the 88th term, please? I don't want to do all the math. I don't want to count 2's till I reach the 88th term. How do I find the 88th term, right? Well, this is when this formula comes handy. We have AN, which equals A1 plus N minus 1D. N represents the nth term. What exactly am I searching for? I'm searching for the 88th term. So I'm searching for A, 88, right? And what is this equal to? Well, it's equal to A1, which is simply 3, plus, well, what is N? Remember, N equals to 88, right? So now I have 88 minus 1. What's the difference? D stands for difference. 5 minus 3 equals to 2, right? So what do I have? I have A88. I'm going to write it down here. which equals to A1, which is 3, plus, well, 88 minus 1, which is just 87, multiplied by 2, which equals to, if you do the math, 82, 160. We got 14, 174, 177, if I'm not mistaken. We have 88, which equals to 177. Instead of counting 2 and taking that would take forever, right? I would rather use a general formula, which is an equals a1 plus n minus 1d. Now, they're asking us to find the first 5 terms of the following arithmetic sequence. You can do this yourself. Actually, let's do it together. A1 equals to 17. What is A2? Well, it's simply A1 plus D, right? How do I do this? Remember, because A1, A2, A3, A4, and A5, we're just adding D to the previous term, right? So A2 would be equal to A1 plus D. We're just adding D. So let me explain this. Let me explain what the arrow means. If I add D to A1, I get A2. If I add D to A2, I get A3. If I add D to A3, I get A4, and so on. So A2 equals A1 plus D. A2 is simply what? Let me write this down. 17 plus D minus 3. A2 equals to 14. You can find A3, which is simply what? A2 plus D. A3 equals 14 minus 3, which equals 11, and so on and so on. You can find A4 and A5. Moving on to this interesting question. We have A1, which equals to 8, A4 equals to 15. How on earth do I find A5? And I'm not even given the difference. So if I write down the formula an equals to A1 plus n minus 1d, and I plug in 5, right? So A5, that's what I'm searching for, equals to A1, which I'm given, which is 8. And then I have 5 minus 1, right? Because this is 5. I'm left with 4 multiplied by d, but the thing is I don't have d. So how do I find d? That's the question. Well, to find d, I'm going to actually use A4. If I have A4 equal to A1 plus, well, 4 minus 1, right? Multiplied by d, I have A4 which equals to what? I have A4 which equals to 14, which equals to A1, which is 8, plus 4 minus 1, which is just 3, multiplied by d. Now we can find d by simply subtracting these two. 14 minus 8, 6 equals to 3d. D equals to what? 6 divided by 3, which is simply just 2. Now, I can go back to the general formula where I have an equal to A1, which is 8, plus n minus 1 multiplied by d, which is simply 2. Now if I plug in 5 for n, I got 8 plus 5 minus 1 multiplied by 2, 8 plus 4 by 2, which simply equals to 16, and that is A5. Now, yeah, the thing is, you could have went from A4 to A5 really quick if you know the difference, right? And yeah, that's it. And you don't really need to do all of this. You could just be like, oh, A4 is 14 after finding the difference, which is 2. A4 to A5, you just add 2, and that's it. You got 16, okay? I just wanted to explain how to plug in D back into the equation, and yeah, give this one a try. Go ahead. You have A3, you have A5, but what is A2? Give it a try, plug in your values, see what you get, try and find the value of A2. So what about this? What is an equal to an minus 1 plus d? Well, this basically tells you that if I want to find the next following term, I just add the preceding term, the previous term, to d. And that's it. You just add d to the previous term. Let's have a look at this question. They're asking us to write a recursive formula for the following arithmetic sequence, which is the following. It's very, very simple. an, you write down an equals an minus 1. Now, what is d in this case? Well, you can do negative 7, right? Minus negative 18, which is simply just negative 7 plus 18, which equals to 11. And then you add d, which is just 11, and that's it. So that is basically it. Now, why are they saying that n is greater than or equal to 2? Because let's say n equals to 1. If n equals to 1, then what are we left with? We're left with a1, which equals to a0 plus d. Actually, no, it's, it could be, it could actually be equal to 1. So if you start with a0, like a1 equals a0 plus d. What they're trying to tell you, if n is greater than or equal to 2, it means that the starting term is a1. So if n is greater than or equal to 2, that means a2 equals to a2 minus 1 plus d, where a2 equals to a1 plus d. So the starting term is simply a1. That's what they're trying to say. But that's not always the case. You could start with a0. You're going to see this, like a lot of questions do have a0 as the starting term. Now let me erase this. Okay. Should we erase any of this? No, we're good. Okay. Now, an explicit formula for the nth term of an arithmetic sequence is given by the following. Well, we just took this, right? So an equals to a1 plus n minus 1 multiplied by d. Now, find the number of terms in the finite arithmetic sequence. Well, before we do anything, do we have the difference? Let's find that, right? We got 1, 8, which is simply 1 minus 8, which is negative 7, right? Negative 6 minus 1, negative 7. So basically the difference is negative 7. Now if I write down an equal to a1 plus n minus 1 multiplied by d, I know that negative 41 is the final term, right? They mentioned the word finite. So negative 41 is in fact the final term, but I'm trying to search what exactly does this term represent? Like what nth term is negative 41? Is it the 50th term? Is it the 30th term? Like what exactly is negative 41? I'm not going to find all the numbers between negative 6 and negative 41 and then just count them and be like, oh, negative 41 stands for that term. No. Instead, I'm going to try my best to use the formula and determine n, which represents the nth term, right? So my main goal is to find n. I know d is negative 7, right? I don't know what the value of n is. I'm searching for that. I know a1 is 8, and an would represent negative 41, right? Because that's what we're searching for. We're searching for the nth term of negative 41. So an is negative 41. We're searching for its n, so we're not going to plug in anything. a1 is 8 plus n minus 1 multiplied by d, which is just negative 7. Now I have negative 41, which is 8 minus 7n plus 7. We got negative 7n, which equals to negative 41. And negative 15, right? Negative 7n equals to negative 56. N equals to the 8th term. And that is it. I hope this makes sense. Now, you could count them, but that would take you forever. Well, not forever, but you to understand how to use the formula. And this is good practice. Yes, please do this question. It's basically the exact same thing, but just like different numbers. Actually, it might be different. Who knows? Just solve it, okay? Now that's it for the arithmetic sequence. It's that simple. Now we can move on to the geometric sequence, which is also very easy. It's actually easier than the arithmetic, maybe? I don't know. With the geometric sequence, we have a common ratio going on. So let me tell you. Let's say we have 2, 4, 8, 16, 32, 64, and what else? 128, right? So in this case, we're simply multiplying by 2. I don't see an addition of 2 going on, which basically means going from one term to the other, I'm multiplying by 2. And that's a common ratio. Well, does it have to be a positive number? We could multiply by a negative number. So let me give you an example. Let's say 2, negative 4, 8, negative 16, 32, negative 64. I'm multiplying by what? Negative 2, negative 2, negative 2, negative 2, negative 2, right? 2 times negative 2, negative 4. Negative 4 times negative 2, 8. 8 times negative 2, negative 16. Negative 16 times negative 2, 32. 32 times negative 2, negative 64. So going from one term to the other, I'm multiplying by a negative number or I'm multiplying by a positive number. It doesn't have to be an integer. It could be a decimal, let's say 1/2. It could be negative 1/3, and so on. Okay? Now let's have a look at example number 1. We have from 1 to 2. Okay, so you don't want to guess this, right? None of us actually want to play games and guess this. So how do I actually do this? It's similar to the arithmetic sequence. With arithmetic, we were subtracting from right to left, right? I would go like 2 minus 1, 4 minus 2, 8 minus 4, 16 minus 8. Now, what am I going to do instead? I'm going to divide. So 2 divided by 1. 4 divided by 2. 8 divided by 4. And 16 divided by 8. What do we get? We get 2, we get 2, we get 2, and we get 2. That's it. So that simply means there's a common ratio going on. Now 12 divided by 48, 4 divided by 12, and 2 divided by 4. Well, 12 divided by 48 is equal to 1/4. 4 divided by 12 is 1/3. 2 divided by 4 is 1/2, which is definitely not a common ratio, which means this is not a geometric sequence. However, A is a geometric sequence. Now, I do suggest we solve the following 2 examples. Moving on to this one. Now, what is the general formula of a geometric sequence? Well, here it is. It's simply an equals to a1 multiplied by rn minus 1. It's that simple. It's similar to the arithmetic where I have n minus 1. So that one would be an equals a1 plus n minus 1d. This one is simply an, which equals to a1, you see the a1, multiplied by rn minus 1. And that's it. It's that simple. So what do I have in this case? List the first 4 terms. Well, you don't really need the formula for now. a1 equals to 5. a2 equals a1 times negative 2. a3 equals to a2 times negative 2, and a4 equals to a3 times negative 2. And that's it. a2 equals to a1, which is 5, times negative 2, which is negative 10. a3 equals to, oopsie daisy, negative 10 times negative 2, which is 20. a4 equals to 20 times negative 2, which is negative 40. That's it. It's that simple. So term 1, term 2, term 3, and term 4. You can do this one on your own. List the first 5 terms of the following geometric sequence. Now, the recursive formula for your geometric sequence with common ratio r in the first term a1 is the following. So they're mentioning the first term is a1, so n is greater than or equal to 2. So the first term is a1. And what exactly are they mentioning? You just need to find the difference, and then you can write the recursive formula. So let's say we have 9 divided by 6, which equals to what? 3 over 2, which is simply 3 halves. And what do we have in this case? an equals to, well, yeah, I would suggest you do an minus 1 multiplied by 3 over 2. Doesn't matter which order you write it, but yeah, that's it. And yeah, this is not a parentheses, my bad. Well, it's an minus 1 multiplied by 3 over 2, okay? Now, you memorize this, and how do we solve this question? Well, we have a4 and a1, we're searching for a2. Well, we don't know the ratio, right? We need to find the ratio first. So a4 equals to a1 multiplied by r n minus 1, right? Now, what is n in this case? It's simply 4. So this would simply be equal to 4 minus 1, which equals to 3. Now, a4 is 24. a1 is 3 multiplied by r to the power of 3. How do I solve this? 24 divided by 3, which is simply 8, which equals to r cubed. R equals to the cubic root of 8. R equals to 2. Now, once you have r, you're basically done with the question. We're searching for a2, which equals to a1 multiplied by r. a2 equals, what is a1? Which is simply 3 multiplied by 2, which equals to 6. Or you could plug it back into this equation where you do a2 equals to a1 multiplied by r, 2 minus 1. a2 equals a1 multiplied by r, which is simply equal to 6 as well. Okay. Oh, that's pretty much it. Now, write an explicit formula for the nth term of the following geometric sequence. How do I solve this? Well, 10 divided by 2, 5, 5, 5, right? Then you do an equals to a1, r, n minus 1, right? an, what's the first term? If we're taking a1, it would be 2. Then r, which is simply equal to 5 to the power of n minus 1. That's it. Now, what else do we have? We have, now this is interesting. If you have 5, actually, if you have an equal to 2 times 5n minus 1, try and get rid of the negative 1. See if you can do that. And find an in terms of n only. I don't want to see a negative 1. If you can find the answer, good for you, because this actually may show up on the AP.